For this video, we'll be doing wave. So for wave, we'll do 1 structured question and 3 essay questions. So let's start. So for the first question, we'll be looking at Malacca. Now, obviously, as usual, this is the episode number 3. You already know that you can actually download the material at the link below. So make sure you download it and do it with me together. Okay, so we look at Percubaan Negeri Malacca first. So for this wave, this is on the electromagnetic wave spectrum. So when we learn this electromagnetic wave spectrum, you need to know about mainly 3 things. 1, 2, 3. Now the first is you need to know about the spectrum. So which is that R, M, I, V, U, X, G, radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. So that is your spectrum. Number 2, you need to know what are the characteristics of your electromagnetic wave. Like for example, they can travel in vacuum, they travel at the speed of light in vacuum, and they are all transverse waves. So as for the spectrum, you also included, you need to know, like for example, radio wave has the longest wavelength, gamma ray has the highest frequency. So the higher the frequency or the higher the wavelength, what will be the difference? Okay. Now, so for number 3, you have to know is the application. Now, sekurang-kurangnya, I suggest you to know at least 2 applications for each radio wave, microwave, infrared, and everything. So it'll be 2 applications each. So make sure you know this. Okay, so let's start our question. They say electromagnetic waves are what? So I told you electromagnetic waves, they are all transverse wave. So when looking at transverse wave punya definition, it is actually they all oscillate perpendicularly. So this is why I said you need to know the characteristics, because the characteristics will tell you that it is perpendicular. Okay? Now then, which one has the highest frequency? So the highest frequency is your gamma ray. So the answer here is we're gonna write our gamma ray. And then which one is to dry paint on cars? Now remember, a lot of students here will actually write UV light. Okay, UV light, if you've seen this before, UV light is actually used to dry when girls do the nails, they have to use the UV to dry the glue on the nails. So that one is under UV. But this is to dry paint. Now paint requires heat. So heat will be what? So which one of this actually produces heat? So the answer is your infrared ray. So here, my answer is infrared ray. Okay? Now, so one characteristics of electromagnetic wave. So just now I said, for characteristics pun, you gonna remember 3. So here, rather than say that they are transverse wave, I'll write something very special. I can say that they can propagate through, or you can say in vacuum. Okay, so this is what makes it very different from sound wave, because sound wave can only travel in medium. Okay, so make sure you know this. So this is our first structured question. We will look at our first essay question now. Okay, for our first essay question, we'll be looking at Selangor set 1, question number 9. Okay, so here they give you a ship to determine depth of seabed. So what is the phenomenon involved? So when you see the wave goes all the way down, bounce all the way up, so obviously this will be known as the reflection of waves. Alright, so this will be reflection of waves. Now next, how this ship is able to determine the depth of the seabed, 4 marks. Now if you watch this video before, especially from episode 1, so we talked about this before, that for 4 marks, we will keep our sentences short and make sure that we break this into shorter sentences. Okay, so step 1, so your wave is produced by who? Produced by the transducer and is sent towards the seabed. So my first marks is I can say that my ultrasonic wave, or ultrasonic, same lah, okay? So you can say that the transducer produces your ultrasonic wave and is sent to the seabed. So I say who produces the wave, then the wave is being sent to the seabed. So this is the first part only, okay? Second part, we talk about what happens at the seabed lah. Then this is where we involve the physics. So you can say the ultrasonic wave is reflected at the seabed back towards the ship. So since when we explain this, it is good that if you can specifically say where is the direction. So this one is sent to the seabed. So after it is reflected at the seabed, then it goes back towards the ship lah. Okay. Then what about my third point? So which thing is going to get back the wave? They even tell you this is your receiver. So you guys don't have to panic. Whenever they give you something maybe a bit more complicated, they will give you all these names of the parts. So make sure you use the words given in the picture. So then we can say your receiver will receive the ultrasonic wave. Okay, US is ultrasonic wave, okay? Or received or will be detected by the ultrasonic by the receiver. And lastly, how to determine the depth of the seabed. So this is where you will then need to say the formula that you will be using. Okay, what's the formula that you'll be using? So we'll be using this thing called the depth is equals to Vt over 2. But rather than just say Vt over 2, we'll say lah, okay, it is the speed of the ultrasound multiplied by ultrasonic wave multiplied by the time taken to receive the ultrasonic, again, divide by 2. So you just have to write this down. So the depth of the seabed can be determined by using speed multiplied by the time taken for the ultrasound to be received, divide by 2. So this is how you get these 4 marks. Now, this question is considered quite difficult because you need to have formula and you need to use all these keywords like reflected and so on. Okay, but should be fine. Okay, then we're gonna look into the calculation. So far in this chapter, we mainly have a few formulas on it. So V equals to F lambda, lambda equals to X over D, or your depth is equals to Vt over 2. So depends on what formula you want to use. Okay, in fact, this chapter is actually very little calculation. So they tell you that they want you to find wavelength, they give you frequency, and then they give you velocity. So when I see velocity, I want to find frequency. Obviously, is the first one already lah. So V equals to F lambda. So if this V equals to F lambda, 1500, what's my frequency? 5 times 10 to the power of 4. Next one will be a lambda. So I can calculate out my lambda, which is equivalent to 0.03 meters. How do you know what is the unit for your wavelength? It will always depend on your velocity kan. If it's in meter per second, your answer will be meters. But sometimes your velocity, they give you cm. So you got two choices, change this to meter, or you get in terms of cm, if this is given in cm. So make sure check what velocity unit you are given. Next, find the depth of the seabed if it's 2500 ms. So what's this ms? Obviously it's millisecond. 3 marks. So for 3 marks question, I will try to write out more detail for my steps so that I can get marks along the way. First step, tukar the 2500 ms. I want to change this to something that easy to accept. So 2500 ms is milli, right guys? Milli is times 10 to the power of -3. If it's times 10 to the power of -3, so this is going to be equivalent to 2.5 seconds. Okay, so I change this thing first. Find the depth of the seabed, Vt over 2. So my velocity is 1500 here, 1500 meters per second. My time taken is 2.5 seconds. I'm going to divide this by 2. Divide this by 2, selepas tu apa you dapat? You dapat 1875 meters. So that's it guys. Very, very simple, very direct. Okay, no problem, right? Okay, next we are going to look at our essay question. So this is a 5 marks calculation, 4 marks explanation, 1 marks definition, then 10 marks on my essay question. Now, so this is about a retaining wall. Now, if you have no idea what is a retaining wall is actually, you can refer to the SABK Agama paper, one of the state paper also. So they show you this thing. This is your retaining wall that will block the wave from kena the pantai and prevent soil erosion. Okay, so it's to prevent the soil from eroding. I mean the water from eroding the beach. Now, in this question, I will give you 10 seconds to decide which is the retaining wall that you want. Alright, so 10 seconds. Okay, time's up. Now, so if I look at this, I will check which is the easiest factor to see first. So obviously, I'm going to look at the height of the retaining wall because obviously, if I want to block the wave, this thing confirm, I want higher the better, right? So a higher retaining wall, tak mau yang rendah. So then after that, what's next? Structure. So obviously, I want it to be slanted like this, right? Correct? Or maybe I want it to be at the bay, right? Correct. So obviously my answer will be at P. Alright. So how are we going to explain this thing? Now this is quite interesting. Okay, so first we're going to talk about why do we want it to be at the bay first. Okay, because at the bay, obviously this thing is more shallow. Okay, if this thing is more shallow, what advantage? Shallow means that your velocity of the wave is lower. If you have a lower velocity, so therefore you can also say your amplitude is lower, so your wave will be calmer. Okay, so I write short form like this, like point form, but in exam, make sure you elaborate your sentences. You can say that because at the bay, the wave is shallower, the sea is shallower, so the velocity of wave decreases, lower amplitude, so the waves are calmer, like that. Good enough, alright? Now, why do you want a sloping retaining wall? This one also quite easy to explain. You can also use back the same thing. Okay, why? Because you can say that if it's a slope, right, correct, we can say as the depth decreases, your speed actually decreases, so therefore you will slow wave, or you can say that your waves are calmer as well. So can your answer stack? The answer is yes. Can it be repeated? The answer is yes. All right. Now, because at the end both will give you a shallow region, but recently got people ask me, teacher, can I write another pattern? Can I say, because at the deeper region, your pressure is higher. Pressure of water or pressure of liquid is higher. So if you have a higher pressure at the base, so therefore what you will need here is obviously you need a wider base to withstand the pressure. You want to withstand the pressure. Is this acceptable? Now the answer is obviously also yes, because it makes sense. If you see all the dam, you know what's dam, right? The empangan, they are all built with a wider base. So if they built with wider base, means that why? Not because one stable, because we want it to, so that when the pressure at the bottom here is larger, so it can tahan the pressure that's acting at the base of the retaining wall, so it won't crack lah. If this one, maybe the bottom will crack first because the pressure here is higher. Okay, can withstand higher pressure located at the base. Boleh. Now, what about this uneven surface? Now, this one, right, is quite a fresh way because recently, how we're gonna explain this one kind of changed already. So, in physics, right, all these questions got fashion one. Okay, got like all these weird punya fashion one. Okay, so what's this fashion for uneven surface? So, if today you have a very shiny surface, all the wave will be reflected and directed to the same point, correct? So like for example, a shiny watch surface, or maybe sometimes when your phone punya surface very smooth and shiny one, right? So when there's a light or maybe the sun, it can reflect on your phone screen, so you will see satu biji light on your phone screen, correct? Why? Because it reflects completely shiny, flat. Now, what kind of surface will not reflect light perfectly? Matte finishing, like matte, rough a bit, right? So why? Because if your surface is a bit uneven, light that is reflected will be scattered. It will how to say, it will reflect towards different direction. So therefore, what's the advantage of this uneven surface? Okay, let me teach you how to write this thing. So we can say that your waves, your water waves, are reflected to many different directions. Okay, so if it's reflected to many different directions, so the energy of waves are split, or you can say are being scattered lah. So they are less focused. The energy of wave are less focused, are split into different regions. So means that the wave won't kena the same spot on the beach, because imagine, right, if let's say this is the beach side, okay, so let's say your water wave always kena the same spot, so this part, right, very fast will hilang one. You will have more erosion at that part, then lying part, right, is all perfect. So we don't want the water to focus at one point, we want the water to scatter, so the whole entire surface will share the energy of the wave. Okay, so this is quite an interesting question. Now next, very typical, okay, this is very easy. Why do we want a high retaining wall? So we want to be able to withstand higher waves, okay, and also to prevent over spilling of waves. Okay, what do you mean by overspilling? So if you have a higher wall, means that the water can go higher, right? Correct. If your water can go higher, means your water won't melimpah, like won't overflow. overspill to the other side. Okay, so it not only can tahan the wave, it can also prevent the water from leaking to the other side. So for this question, I think it's quite interesting because this uneven surface is quite special, and this structure of the surface also offers two different ways to look at it. You can see via because you want to reduce speed, or you can also say want to tahan the pressure. Pun boleh. Okay, Ken? Alright. Okay, so this is on our second essay question. First essay question. This first essay question, we'll look at our second essay question. For our second essay question, we'll be looking at our percubaan negeri Perak. Okay. Now, so this is very interesting because they talk about later. They want to say wave particle duality explained. So this is actually quite special because you have to explain wave particle duality, which is your quantum physics. So let's see. Now, what is an electromagnetic wave? Now, actually, right, what's the electromagnetic wave is rather simple. What is it made up of? It is made up of two things. Okay, guys, guess what is this? It's called electromagnetic. So it's made up of electric field and also magnetic field. Okay, so it's basically waves that are made up of electric field and magnetic field that oscillates perpendicularly to each other. Okay, what do I mean by this thing? Okay, this is actually saying that electromagnetic wave, there's a magnetic field, there's an electric field, and they're always perpendicular. So what is your keyword here? Electric field, magnetic field oscillate perpendicularly. So that's your keyword that you cannot change. Other words, you can say maybe to one another, to each other, suka hati. Alright? Okay, now this is gonna get very interesting. Wave particle duality. How are we gonna answer this wave particle duality question? So first of all, okay, we study first and second mark first. So why light can have wave particle duality? Because your light, we can say your visible light behaves like wave. Because what can it do? Remember, when something is regarded as a wave, it must be able to do, because it can undergo diffraction, and also your visible light can also undergo this thing called interference of wave. Okay, so when whatever can undergo diffraction and interference, it will be considered grouped as your wave, right? Under the wave family. Okay. Tapi kalau you want to join the particle family, so particle family says what? Okay, then we can say why visible light can behave like particle. So why visible light can have particle properties? Because such as it has particle properties such as momentum. Okay. So, and besides that, your visible light also has kinetic energy. Okay, if you have kinetic energy and momentum, this means that, okay, because the momentum is what? Momentum is mv this is momentum Kinetic energy is what? Half mv square So the moment you have mass and velocity, momentum, if you have momentum, you sure have kinetic energy, okay, because it's mv. So when you have mv and half mv square, you will be regarded as a particle. So like us human, we are considered as particles because we have momentum, mass, velocity. So I cannot diffract, I cannot go interference. So therefore, I'm particle. I'm not a wave. Okay, but you should study this thing called de Broglie wave particle duality lah. So maybe a particle can also behave like a wave. Okay, so more on that in other episodes. So jom kita continue to tengok this 4 marks. Okay, so very simple. We talk about diffraction, interference. We talk about momentum and kinetic energy. So 4 points. You get 4 marks on the wave particle duality. Okay, now we're going to look at this communication station. Now, you are supposed to find which is the best for a transmitting station. So remember, anything that goes to the sky, anything that have to go all the way to the outer space, ataupun it is a radar, whatever that, fine aeroplane, confirm we will use microwave. So I won't even want to give you 10 seconds to do this because I think this is very easy. So we want this to be a microwave. Why? We'll talk about it later. Obviously, this radar or what transmitting station must be higher, and obviously the diameter has to be bigger. So my obvious answer here is X. Why is it X? Okay, jom kita tengok. Now, why it is a microwave? So we can say because microwave actually has higher frequency compared to radio. Radio is the lower frequency, okay? Because it's Ryan May I. So this has a higher frequency compared to the radio wave. Higher frequency compared to the radio wave. So frequency higher, so you actually have a what? Higher penetrating power. Then if you have a higher penetrating power, then I can say so that you can actually travel further. Because penetrating power means that it can go further. It can fly further. Okay? Wavelength longer is not go further. Frequency higher is go further. Wavelength longer, another answer. We'll talk about that later. Okay? So higher penetrating power, or you can also say high energy. Okay, why do we want this to be a higher position of the transmitter? So therefore, that it is less likely to be obstructed, or therefore there will be less obstacles that will block. Okay, or you can say less obstacles obstacles to block the signal. Okay, so therefore this is on your higher. Okay, actually very easy to write for higher transmitter, a lot of answers to write. Okay, what about your frequency? Okay, why do you want this to have a 3 something? Okay, a higher frequency punya advantage is actually you can say that it has a higher energy. Okay, you can stick back to the same answer. Oh, so that you have a higher penetrating power. Wow. Then the past two, what else can you say? Wow, so you can travel further. You can stack the answer. But a higher energy is actually a very good answer. Why? Because you want to send signal, transmit signal. And a higher frequency, why I can write high energy is because you remember E equals to HF, a higher frequency means you have higher energy. So you can travel further, dan sebagainya. Okay, can more signal, more information can be sent and everything. Okay, what about the diameter of this parabolic disc, which is this one lah? How big that dish should be lah? So a bigger dish means that you can capture and receive more signal. Done. Very simple. More signal can be received and so on. Okay. Now, but you must be very sensitive to one question that they like to ask. Some they ask, where should this receiver be located? Remember, it has to be located at the focal point. Okay, why? Because all the signal that is reflected will converge to the focal point. So this one also a hot question. Make sure you know what you are doing. Okay, like what is converge receiver? It will converge to the focal point. Where should the receiver be? At the focal point of the concave parabolic dish. Okay, we don't say this as a curve. We call this as a concave parabolic dish because it's curved inwards, concave shape. Okay, so therefore, oleh itu, my jawapan in this situation is I will pick X as my answer. Okay, can? Now next we'll look at the bottom part here. So another 4 marks of calculation. So most of the essay 5 marks of calculation. Essay will have 5 marks of calculation. So standard lah. Okay. So what's the trick here? They gave you the wavelength in cm. What should we do? Change to meter lah. Easier. So 1 times 10 to the power of 4 cm is actually 1, 2, 3, 4 cm. So which is actually equivalent to 100 meter. Because why? I divide by 100 to change it to meter. Okay. Find the frequency of this wave. So we have V equals to F lambda. So my velocity is how much? The speed of the electromagnetic wave spectrum is this thing times 10 to the power of 8. Okay, my frequency. So how much is my wavelength? 100 meters. So what is my wavelength here? So what's my frequency here? So it will be 3 times 10 to the power of 6 meters. No, not meters. This is frequency. So this will be 3 times 10 to the power of 6 hertz. That's it. Very simple. Okay, because it's frequency. Now, so if determine the speed of the microwave if refractive index is 1.333 through water. Okay, you must remember when we calculate refractive index, there's always speed of something divided by speed of something. Vacuum over medium. Okay, so in this case, vacuum over what? Your medium choice is water. So we take water. So this is 1.333. Vacuum over water. Now, vacuum standard one, alright? So they will give you this number, 3 times 10 to the power of 8. So divided by the water one, and then equals to 1.333. So you just have to press, divide. Then your water, the speed of light in water is 2.25 times 10 to the power of 8 meter per second. Okay, I teach you one secret. Now, in exam, if you suddenly forget, which one is on top, which one is at the bottom, that is a secret. Okay, you ask yourself, vacuum lebih cepat, vacuum faster or water faster? Which is actually faster? Vacuum faster or water faster? Of course, vacuum faster, right? Because vacuum got no resistance, no nothing, right? So it means water will be slower. So if you want to become slower, do you multiply by 1.333 or you divide by 1.333? If you multiply, the number becomes bigger. If you divide, the number becomes smaller. So if you want it to become slower, you divide it. So if you forgot like whether you need to put on top or bottom, you just think, if the number is supposed to become bigger, you multiply this. If the number is supposed to become smaller, you just divide that. So in this case, because water is slower, I will divide this. I get 2.25 times 10 to the power of 8. Okay, Ken? Alright. Now, so welcome to our last essay question. For our last essay question, okay, what we'll be doing is our Negeri Pahang paper, alright? So let's have a look here first. So a very typical question for this is your question 11. They'll call you to do a bunch of comparison. Okay, for this kind of comparison, it's a 5 marks thingy. So the most important thing that you need to do here is you have to, like pick up all the 5 points that you're supposed to do. So here you're supposed to compare the amplitude of the wave, compare the number of complete wave, compare the period of oscillation. So it's actually very simple. You see, the amplitude is the same, height ma. Then number of waves, this one got 1, 2, 3. This one only got 1.5. So this is more than that one. What about the period of oscillation? This one much longer. So therefore, the period of oscillation is terbalik. Number of wave, this one more. Period of oscillation, this one more. Because frequency and your time is terbalik. Alright? It's very simple and just write only. Then after that, the number of complete waves with the period of oscillation. So the higher number of complete wave, the lesser the period of oscillation, because more wave means shorter time. And then after that, your number of complete oscillation with the frequency of wave. So the higher the frequency of the wave, the higher the number of complete oscillations, because frequency is your number of wave. That's it, guys. Okay, so these 5 marks, you'll be able to do it. It's 1, 2, 3, blue color 4, red color 5. Very simple. Okay, so what is frequency? It is the period is the time taken. So frequency is the number of complete oscillations made in 1 second. It's like in 1 second, like this, how many waves can you get? So that is your frequency. How many waves can you get in 1 second? Alright. Now, we look at this 4 marks question. Now, recently for this 4 marks question, it's quite a hot topic. Alright. Now, so for this 4 marks question, I'm not going to discuss in this video because I will be holding a Sunday 4-hour revision right 1 day before SPM happens, which is on the February 18th. Okay, so in that 4-hour class, I will be spamming a lot of state paper questions and also some of the questions that I picked from a lot of revision materials that I've been through. So in that 4-hour class, we'll be like maximizing all the questions. We'll just practice everything. So if you're interested to join my 4-hour class, feel free to leave a comment at the section below. I'll get in touch with you. Alright. Okay, so this one, we'll keep it to our Sunday class. Now, the last part of our essay question is a wireless router. Now, this is a very a lot of people say, wow, this one will come out. For the past 3 years, everybody has been predicting this to come out already. But so far haven't come out before lah. Okay. So now let's just talk about this one. So this is a design question. So what do they need us to do? So the location of the wireless router, simple. The type of electromagnetic wave used, simple. Frequency of the wave, simple. Density, also very easy. And the number of antenna used. So if this question were to come up as an essay question, the only thing that you have to worry is, do you know how to explain properly? Okay, so let's talk about the first one, the location. So location is where we must say the location of the transmitter is obviously higher Okay, why do you want this to be higher? So that it is less, it will not be blocked. Okay, what? Your signal will not be blocked by surroundings. Okay, because in your house, maybe you have like, um, let's say some racks, let's say some something that you hang is very high and so on and so forth. Okay, so it will not be blocked by surroundings. Yeah, good enough. Okay, number 2, type of electromagnetic wave use. Okay, so guys, wireless router need to go to the sky or not? You don't need to sit aeroplane later pass by your house, right? Then you connect your house Wi-Fi, right? Correct? So the answer here is we don't use micro. For this one, the choice is we want it to be radio wave. Okay. Remember just now I said how to see why radio wave. So radio wave has one advantage because it has the longest wavelength. Okay, it has the highest longest wavelength. So a longer wavelength means that there'll be more diffraction of waves. Okay. So this is not penetrating power already. Frequency is related to more penetrating power, higher penetrating power. So if you have more penetrating power, you can travel further. But if you have more diffraction, then what is the advantage you have? You will actually have a wider coverage, or you can say so that your wave can transfer to a wider, larger area. Okay, so this is a wider coverage. So don't say wavelength big means travel further. Your radio wave cannot travel, let's say, to 5 house away. Okay? Now, so this is longer wavelength better. But then here you have a very contradicting point. 2.4 GHz, 5 GHz, which one do we use? We will use the 5 GHz. So we say high frequency of wave. Then tiba-tiba here we say high frequency. Okay, you nampak or not? On top you say you want longer wavelength. Bottom you want longer frequency. So which one you want now? Okay, the answer is we want to pick radio wave. So the family of radio wave. But in that radio wave family, we will pick the higher frequency, which is like maybe like you want to choose the rich people gang, but you choose the poorest in the rich people gang. So it is still a radio wave, but in that radio wave family, it has the highest frequency, which is the 5 GHz. Okay. Now, when you have high frequency, means you have more signal. If you have more signal, what's the advantage? So you can see now more signal can be transmitted at the same time. Okay. Means 1 second, I can transmit 5 giga wave. If you use 2.4, your speed is half because 1 second you can only get 2.4 gigahertz. So this one, right, what they are trying to catch you, what is the mistake that they want to what's the trap they want you to set is that some people will say higher 5 gigahertz, your internet will be faster. Okay, in physics, when you say internet faster, your teacher will say that cannot because the wave go faster. No, the wave is still the same, but now you transmit more wave. If you have more wave, means that your internet will be faster, your download speed will be faster, but that doesn't mean that the wave go faster. Okay, so why your internet is faster? Because more signal can be transmitted, your download can be faster, your upload can be faster. Okay, now density of material. So remember in June House class I very pantang one. Low density cannot straight away say light. Low density, why? Because so that it has a lower mass. Because density affect mass, then only we can say that it is lighter and this is going to be more portable. It's lighter and it's more portable. So remember, you must have all these answers to back up yourself. Like for example, longer wavelength. Why must write more diffraction? Because more diffraction will explain that this is wider coverage. So these two answers is like both also must write. Okay, so that your answer is more complete. Okay, remember Jung Hao punya schema is like very strict one. So SPM would be strict, but mine is like even more strict. Okay, last point. Okay, so what's the last point here? So number of antenna use. So router, the more antenna you have, the better it is. Because why? So that a lot of antennas can send different signals, right? Correct? So you can say more number of antenna used. Okay, you need to have more number of antenna use. Okay, so if you have more number of antenna use, apa so good. So the answer is that you can say more signal can be transmitted. Okay, why? Because let's say one stick used for your dad to watch Astro, maybe. One is for your mom to video call with the auntie. One is maybe for your sister to watch Insta. Maybe one is for you to watch YouTube, like my video, right? Okay. So in this case, more signal can be transmitted because each antenna support different people. Alright, if you maybe like feel like, oh, this is very hard to say, or hard to think. I don't have to write at the same time because this is more signal. I don't need to write at the same time. So it can be transmitted, or you can say so that it can cover larger surface area. Okay, why? Because the signal will be stronger. You have more antenna, means that you actually transmit stronger wave. Alright, can? So therefore, this is our question 11, whereby this is unguided. There's no PQRS. Okay, shout out to the people who help us to compile this state paper by topic. So for wave, this is it. I hope you learned something through this video. We are now 48 hours to SPM physics. So if you think this is good, maybe you can share it with your friends to look at the few essays at the back. Alright, so thank you everybody.